What our next question says that a circular insulated copper wire is twisted to form two loops of area A and area 2A as shown in the figure. At point of crossing, the wires remain electrically insulated from each other. The entire loop lies in the plane of the paper. Okay, a uniform magnetic field B points into the paper, into the plane of the paper. At t is equal to 0, the loop starts rotating about the common diameter as axis with a constant angular velocity omega in the magnetic field. Which of the following options are correct? We have to tell. Now in this case, we can say that magnetic flux will be equal to B vector dot A vector. And if I talk about the A vector, one of the loop will have a direction in one direction and other loop will have direction opposite to the first loop, and the actual area which we will have, that will be equal to 2A minus A, that will be equal to A. Okay. So our first option, we say that the EMF induced in the loop is proportional to sum of areas of two loops. This looks like a wrong statement because it will be subtraction of the two areas. So this A is a incorrect statement. Anyway, so this B dot A, or we can write it as BA cos theta. Initially, we know that maximum flux is passing through the loop. In this case, we can write it as BA cos omega t, because now theta will change at a speed of omega. Okay. If I talk about the induced EMF's magnitude, it will be equal to d phi m divided by dt, or I can say it is equal to BA omega sin omega t. I have not considered the negative sign because I am only interested in the magnitude part of it. Okay. So now what it says that the rate of change of flux is maximum. Rate of change of flux, basically it's talking about induced EMF, is maximum when plane of the loops is perpendicular to the plane of paper, or we are talking about when this omega t will be equal to 90 degree. When omega t will be 90 degree, at that time E magnitude will be maximum, or we can say that d phi by dt will be maximum in the magnitude. Okay. So our option B is correct. Now the net EMF induced due to both of the loops is proportional to cos omega t, which is not true. We have just found that EMF is proportional to sin omega t. So this is our wrong statement. Next says that the amplitude of maximum net EMF induced due to both the loops, this is equal to both the loops, is equal to the amplitude of maximum EMF induced in the smaller loop. In smaller loop, again we have the area A, and if we talk about both loops together, then also we have same area. So in both the cases, the EMF which will be induced will be equal to each other in magnitude. Okay. So our option D is a correct choice.